Hello everyone, in this tutorial I will discuss NumPy in Python. So what is NumPy? So NumPy is Python library that we will use for working with arrays. So it is a Python library used for working with arrays. And it has also functions for working in domain of linear algebra, Fourier transform and matrices. And why we should use NumPy? Because we have discussed list in Python, and list serve the purpose of arrays, but they are very slow. On the other hand, NumPy provides array object that is up to 50 times faster than the traditional Python list. So we will discuss NumPy in this tutorial. And why NumPy faster than list? Because as you know that in array the elements are stored at continuous places in memory, but in case of list the values are stored in are not stored in continuous place. So NumPy arrays are stored at continuous place in memory. So NumPy arrays are stored at one continuous place in the memory, are stored at one continuous place in the memory. Okay, so in this tutorial I will discuss NumPy, how you can use NumPy. So let's start. For using the NumPy, you will import a package in NumPy. So import package NumPy. So import NumPy as np. And how you can create a NumPy array? You will simply use np dot array, and here you will pass the values. For example, array has value 1 2 3 4 5, and if you print array, and let me show you the output. You can see the output is array 1 2 3 4 and 5. And if you want to print particular values, for example a0 and a1, you will simply write a0 comma a1, and you can see the output 1 comma 2. The array has been created. And if you want to use a0, this, okay, just wait, a0 and this, and let me show you the output. It will show you from 0 index to all the values. And if you write like this, a2, and it will show you the value from second index. So this is the 0 index, 1 index, 2 index, 3 index and 4 index, and a2 colon, it will show you the values from second index to the end of the array. And if you write a1 colon 3, okay, it will show you the value. See, a1 means first index to first index and then second index. It means up to the third index. So only these two values will be printed. From one index to it, here 3 means up to this value. It will not include this value. Only these two values will be printed. And if you write like this, a1 minus 1, what it show you? So this is, let me show you the array again. So this is the array, and if you write a1 minus 1, and you can see it will start from one index and up to here -1 means to from last values to -1 up to this value. And if you write a1 -2, and you can see 2 3 -2 means there are total 5 values and up to 3 values only. -2 means it will start from 1 index to -2. So it's very simple. So let's create another NumPy array. So b equals to np dot array, and this time I will give some 0 -0.5 1 1.5 and 2, and let's print this b. So you can see this array, and if I print b and 0 3 -1, it means it will print 0 index, that is this value 0, third index, that is this value 0 1 2 3 this value, and -1 means from the last this value. So in the output it will what's the problem here, 0 3. Okay, fine. And if you want to give values like this, then you will use double square brackets. Okay, fine. So 0 3 -1 means 0 index, third index, and -1 index. And similarly you can print the data type of the array. For that you will use .d types. So it is of integer type. A.d type is of integer type because I have used only integer values in that. And if I print the data type of b, so b.d type, and if I run this, and it will show you the data type as float, because this b array has float values as well. So it's very simple. And now I will discuss multi-dimensional array in multi-dimensional arrays in NumPy. So let's discuss. For multi-dimensional array, for example, m is the name of the array, and np dot array, you will use np dot array, and then parenthesis, and then square brackets. Okay, and you will provide the value of first row, and then comma value of second row. So this way you can create a two-dimensional array. And if I print m, let me show you the output, and it will show you the two-dimensional array. As you can see, it has 3 columns and 2 rows. So this way you can create multi-dimensional array in NumPy. It's very simple. And if you if you want to see the number of rows and columns in a multi-dimensional array, so you will use m dot shape. So what m dot shape? M is the name of the multi-dimensional array. It is dot shape return the number of, it will return number of rows and columns. So m dot shape, and if you run this cell, fine, it will show you there are 2 rows and 3 columns. As you can see from the array, there are 2 rows and 3 columns. So dot shape return the number of rows and columns. And if you want to print the number of dimensions this array has, you will use name of the array m dot n dim. So m dot n dimension returns the number of dimensions. So there are two dimensions. It is a two-dimensional array. There are two rows and three columns. And if you want to print the total size of the array, so total size of array, you will use m dot size. So you will use m dot size, and if you run this cell, you can see the number of total size of array means what? The number of elements in array. The number of elements are 6. So m dot size returns the value 6. So it's very simple. So let's create a three-dimensional array. So three-dimensional array. So far I have created a two-dimensional array. For creating a three-dimensional array, it's very simple. What you will use, suppose name of the three-dimensional array is t, and you use np dot array and this, okay, and here you will use like this. So this will, and here you will use, let's say this is the first row and it is the second row, okay, fine, and another value again first row 1 4 6 and again second row, let's say 2 8 and 1. So this is the three-dimensional array, and if you print this array t, you can see the output. It is a three-dimensional array. And if you want to see the shape of the array, t dot shape, okay, so it is the third dimension. There are two dimensions, and in each we have two rows and three columns. So two rows and three columns, and there are total, in the third dimension there are two values, one value this one, second value this one, and in each dimension we have two rows and three columns. So this way you can print the shape of the array. And if you want to print the size of the array, you can simply write t dot size, and there are 12 values, so t dot size prints the number of values I have already discussed. And if you want to print the number of dimensions, t dot ndim, and there are 3 dimensions in this np array, you can see. So next I will discuss indexing and slicing in the np in the two-dimensional array. So let's discuss. So let's create another array. So np dot array, and let's create a two-dimensional array. So 3 5 7 first row, and 2 6 8 second row, and let's 11 4 15. Okay, so let's print s, and you can see it is a two-dimensional array, 3 rows and 3 columns. And what if I print s1? And if I print s1, it will print entire row. So this is the 0, this is the 0 index, this is the 1 index, this is the 0 index, 0 1 and 2 index. And if I print s1, it will return me the second row. And if I write s1 and again 1, it will print the second element of the second row, because here index starts from 0. So S11 will give me 6. S11 will give me 6. Fine, it's very simple. And you can also write like this, S11, and it will give me 6. So there are two ways of writing. Either you can use two square brackets, or you can write like this. Very simple. And what if I write S from 0 index to this, and it will give me the first two rows. So this is the first row, second row, from 0 to 2. Remember, when I write like this, it does not include this index. So it will only include 0 index and 1 index. So it will print entire row 0 and 1. And what if I want to print, let me write first so you will understand it better. So every row and column up to 2. If I want to print every row, and as you can see there are 3 columns, but I don't want 3 columns, I want columns up to 2 only, then what I will write, see, every row, and in the every row up to column 2 I write like this. And if I run this, you can see every row and only 2 columns up to column 2. It's very simple. And what if I want to change the value of this NumPy array? For example, if I want to change, and let me print the entire array first, okay. And if I want to print change the entire row, for example, if I want to change this entire row 268, then what I will use, I will write S1, because this is the here 1 means second row, np.array, and here I will give a new values 33, 53, and you can write any value. And if I print S again, you can see the difference. So entire first row has been changed. If I write like this, S1 np.array, entire row has been changed. And what if I write like this? What if I assign S2 to, let's say, 55, okay. And if I run this, and if I print this, and you can see every value has been changed. If I write 99 and click run, every value of the, here S2 means third row, every value has been changed. So this way you can use index slicing. You can change the value of the NP array. So this way you can use NP array. So this is the basics of NP array. In the next lecture, I will discuss some operations on NP array, and I will discuss how you can use statistics on the NP array. Thank you for watching. Hello everyone. In the previous part, I discussed NP array, NumPy array in Python. So in this part, I will discuss how you can do the operations on the NP array. So first of all, I will discuss statistics functions. So let me write statistics on NP array. Okay, for that I will create a new np array. So p equals to np dot array, and here I will give values 3, 5 and 6. So let me first of all print this. Okay, so this is the np array, and now I will perform some functions for some statistics, and p is the numpy array, and if I use p dot sum, it will add all these values. It will find the sum of all the values in the np array. You can have as many values you can, and it will find the sum for you. So 3 plus 5 8 plus 6 is 14. And if I use p dot mean, p is the name of the np array, and it will find the average of all the values. And you can use round functions that I will not discuss here. Simply I want to use a statistics function, so sum and mean. So you can see it has given me the average of all the values. Similarly, if you want to find the variance, and you can see the variance has been calculated. So it's very simple. You can use many statistics functions, okay, on the np arrays. So in the previous part I have created one np array, that is the s. So let me show you the output first. So this is the s, and what if I want a column wise sum of this two-dimensional array, column wise sum? So I will write s dot sum, and here I will write x is equals to 0, and if I run it, okay, you can see the output. So it is the column wise sum. So 3 plus 33 36 and 99 is 135. 5 plus 55 60 plus 99 159. So if you want the column wise sum of two-dimensional array in np, you simply write name of the array dot sum, and in the parentheses you use x is equals to 0. And if you want to find the sum of the I have calculated column wise sum, and if you want a row wise sum, then what will you do? You will write s name of the numpy array dot sum, and x is equals to 1. So if I run it, you will see the row wise sum. 3 plus 5 8 plus 7 15, and similarly for other values. So for column wise sum you will use x is equals to 0, and for row wise sum you will use x is equals to 1. Very simple. And now I will discuss some NumPy operations. So let's discuss one by one. So if there is one if you want to create a NumPy array, you can also use like this: np dot arrange, okay, arrange, okay, and 4. And if you print it, you can see the output 0 1 2 3. And if you write np dot arrange, let's say 9, and print, you can see 0 1 2 3 4 5 6 7 8. So this is the very easy way of creating np array if you want a np array of a particular range. So it starts from 0 to up to this index. I have already explained this index will not be included, so 0 to 8. And what if I write a plus 5? So now I will explain NumPy operations. So if I write a plus 5, it will add 5 to each of the value. Very simple. And if I write a dot 6, it will multiply each value by 6. So this is the original array, and if you multiply a dot 6, simply you can see it has multiplied each value by 6. Very simple. But remember one thing, if you print A, you will get the original array only, because I have not stored this in any another NumPy array. I am just performing the operations on the NP array. Okay, so let's create another NP array. So b equals to np dot array, and let's say 11 3 55 6. This is the B array, and let me create another NP array. So np dot arrange for, let's print B and C. Okay, let's run this code. So okay, let's print a B here and C here. Okay, so these are two NP arrays, B and C, and I have explained both ways of creating NP arrays. Either you can create NP array this way, and if you want an NP array of a particular range, you can create like this. The main thing that I want to discuss is you can perform operations on two NP arrays as well. So if I write B plus C, you can see the output. So it has added corresponding value of each NP array, and if I write B multiplied by C, it will multiply the corresponding values of these arrays. So 11 into 0 is 0, 3 into 1 is 3, you can see. So you can perform operations on two NP arrays as well. So let's discuss a Boolean arrays also, and suppose if I write like this, A equals to np dot, again I want to create one array, np dot arrange for. Okay, and if I write like this, I will specify values. So first value, let's say, is true, and then false, you can and then false, and then true. Okay, and if I print A, you can see all the values, and if I write A greater than equal to 2, you can see A greater than equal to 2 means 0 is greater than equal to 2, it is false. 1 is greater than equal to 2, again it is false, and other two values are true. And if I want to print which values are greater than equal to true, which indexes are greater than equal to 2, it will give me the output second index and third index. So second index and third index are greater than equal to 2. Okay, now let's create NP array using random values. So D equals to np dot random dot rand int 100 and size equals to 3,3. And if I print D, very good. So you can see it will create a array, two-dimensional array, because I have given two dimensions here. It will create two-dimensional array of random values within, so maximum value will be 100, so up to, so I have given a range here, and size is 3, 3, and if I write size 3, let's say 4, and if I click here, you can see it has created a random array. So random array will be very beneficial. So you can change a value here also. You can change let's say 50. Okay, just wait. You can change a value here. You can write, you can change value here. You can change like this 50. Let's just wait, there is some problem. So 50 comma size equals to 3, 4, and let's print D. Okay, you can see. So this way you can create a random array in the NP as well. So it's very easy. So I have explained all the operations on the NP array, all the basic operations on the NP array. Similarly, you can also perform the matrices operations on the NP array. So let's create a two-dimensional array. So a np dot array. So let's create two-dimensional array. Let's say 1, 2, 3, comma, let's say any value you can give. Let's say 4, 5, 6, 4, 5, 6, and 7, 8, 9. So this is the one array, and let's create another NP array. So np dot array, let's create two matrices, and it has values 1, 2, and then 3, 4, and then let's say 5, 6. So these are two matrices, these are two-dimensional arrays. Let's run this code. Okay, and now what I will do, I will perform dot operations. So matrix dot operation, a dot b, and if I print it, you can see the dot operation of these two matrices. So you can create matrices using NP array, and then you can perform a dot operation. You can perform matrices operations as well on the NP array. So you can see it is 3 into 3, and it is 3 into 2 matrix. You can also find the transpose of a matrix. For that, you will simply, for transpose, you will simply write b dot t, and let's run this code, and you can see. So original b array is this one. Let me show you the b array, and then you will see. So this is the b array, and this is the transpose of the array. You can see. So this way you can perform matrices operations on the NP array as well. So thank you for watching. I have discussed all the basic concept related to NP array. Thank you for watching. Hello everyone. In this part I will explain Pandas series. So let's start. So what is Pandas series? So let me write in the comment. A Pandas series is like a column in a table. So it is like a column in a table. So it is one-dimensional array. Actually it is one-dimensional array holding data of any type. So let's start Pandas series. So for that you will import Pandas as, let's say, PD. So I will create a new series. So for creating a new series, let me write my series equals to, you will write PD is the pandas dot series, and here I will have some values, for example. So let me create some values. And let me, okay, so these values are fine. And if I print this series, so if I write my series and run my code, okay, you can see the output. So my series, you can see pandas.series, and this is the series that I have created. And if you print, its data type is float, because I am providing the float values to this series. And you can see, you can also give the name to this series. So for giving the name, you will write your series, my series dot name, and here you will write name, for example, price in, let's say, 100. And if you again print, if you again run this code, you can see now the name of the series is price in 100 and data type is float 64. So Pandas series is very important. It's like a column in a table. We will discuss data frames in the coming lectures. So series is like a column in a table, so it's one-dimensional array holding data of any type. So next, if you want to print the type of the data type of the series, you will simply write a series name and then data type, and again run this code, and you can see the data type is float 64. And if you want to print the values of this series, simply write series name and then dot values, and you can see the values of the series. And you can also print a particular value of a series. For example, if I write my series and here I provide the index, so by default it is a series array, so 0 index, this one 1 index, 2 index, so it will print 6.79. so you can see I can print a particular value from a series. And similarly, you can also provide the index to a series. So my series dot index, and here you will provide the index, let's say A, C, let's say B, D, and then E. Okay, and now if you print this series, so let me show you the output, and you can see now these values have some index now, the series value. And let me show you the old output first. So you can see if I don't provide any index, then by default index names are 0, 1, 2, 3, 4, and these are the values to a particular index. But now I have provided the index to the series, you can see, and now you can see the values A, C, B, D and E as an index to this series. Very simple. And now as you have provided index, you can print the value of a particular index For example, if I print my series, let's say C, and you can see the index of this value only. So my series C, and you will get the value 2.45 because I have provided index to all of these values. So if you can also use iLocation, so let me first of all write in the comment what is iLocation. So it is using numerical positions. What does it means? For example, if I write my series dot iLocation, and here if I provide value 1, and let me show you the output value. Output is 2.45. Why? Because iLocation 1 means this is the location 0, location 1, location 2, location 3, location 4. So it is the numerical positioning of the locations. So if you print my location dot my series dot iLocation 1, you will get the values. And now suppose I want to select multiple values from this series. Select multiple values. For that, what you will do, you will simply write name of the series, and then here you will pass the indexes. So I want the value of A index and B index, and if I click on run, you can see the value of A index and B index only. So this is my series, and from this series I am getting only the value of A and B only, and you can see I am getting the value of A and B only. And similarly, by using location, you can also get the values from my series dot iLocation, and here I will pass the locations. So 1, 3, and if I run, you can see C, D. Why this is the output C, D? So let me again show you the output. So I have passed index 1 and 3. So this is the 0, 1, 2, 3. So I am getting the value of 1, 3. So C, D, I am getting the values. Pretty simple. So this way you can use series. Okay, so very simple. So next is, if you want to, for example, I want to print a limit, let's say. So of my series, if I want to use a B and colon E, and if I print this, you can see the values from the values of B index to E index. So B, D, E. Why I am not getting the value of C index? Because you can see in my original series that I am getting the values from B index to E index only. So B index to E index only. So this way you can use a limit. And let me again print this series. Now I want to perform some operations on the series. So what if I multiply this series by, let's say, 100, and if I run, you can see every value will be multiplied by 100 if I multiply the series by 100. Very simple. And what if I write my series is let's say greater than, let me again print the series first. So my series, and now if I print my series greater than 5, and if I run this code, you can see 1.36 is greater than 5, it is false, so I am getting false. Again 2.45 is greater than 5, it is false. Next value is true, again true, and then false. And what if I want to print the values of values from the series where this condition is satisfied, then I will write like this. So my series greater than 5, and you can see, you can print only those values from the Pandas series. Very simple. And you can let me again print the values, and you can also perform some statistical functions. So my series dot mean, so it will find the mean values of Pandas series. You can see, very simple. And what if you want to print only those values which are greater than the values from mean? So my series, I will pass series and greater than my series dot mean, and let me run this code. So only these two values have value greater than the mean value of the series. And what if I want to print the standard deviation? So if I run this, you can see this value. We can also change the values of a series. For that, let me show you the series again. So this is my original series, and now suppose I want to change the value of a index. For that, you will write series, and then here you will pass index, and you will set a new value here. And again, okay, so first of all I change the value, and then again print series, and then again run, and you can see the value of a has been changed. So it's very simple. And what if I want to change the value of multiple, I want to change multiple values from the series? For example, I want to change all the values which are less than 5. So my series less than 5, all the values which are less than 5, to set all the values to 9. So set all the values of series which are less than 5 to 9, and then print the series. And you can see all the values which were less than 5 in the series, only two values were less than 5, this and this, and now I have set these two values to 9. So very simple. So this way you can use Pandas series. So I hope you have understood all the concepts, basic concepts of the series. You can create a more series, and you can print the values, you can change the name of the series, you can print the data type, you can print the values of a series, and you can print value of a particular index. You can change the index of the series. Okay, you can use I location. You can select multiple values from the series. You can select values from a range. You can apply any arithmetic operation on the series. Okay, you can find the mean. You can print the values based upon a particular condition. For example, I am getting all the values which are greater than 5. You can print the mean, you can print the standard deviation, you can change the values. Here I am changing all the values which are less than 5 to 9. So this is all about basic concepts of Pandas series. I have explained with practical. So thank you for watching. Hello everyone. In this part I will discuss Pandas data frame in Python. So first of all I will give basic introduction of data frame, and then I will use pandas to read file from the CSV. So let's discuss. So first of all, what is a data frame? A pandas data frame is a two-dimensional data structure. In the previous part I have covered series, and now I am covering data frame. So data frame is a two-dimensional data structure like 2D array, or you can say it is a table with rows and columns. Okay, so how you will use pandas data frame I will cover in this tutorial. So first of all you need to import pandas. So import pandas as PD. So I will create a student data frame. So how to create? It's very simple. Just type a name, and then here you can see the pandas data frame is a two-dimensional data structure. It is a 2D array, so it will have rows and columns. So there are two columns in this data frame. So marks, and let's say marks are 320, 400 and 350, and age, and let's say age is 21, 23, 22. Okay, now you have created a data. Let's load the data into a data frame object. So load data into data frame object. For that, what you will do, you will create an object. df is data frame, pd dot data frame, and here you will pass the name. Okay, so let's print this data frame. So let me explain. This is a student and it has marks and age, you can see, and I have loaded this data. It is a two-dimensional data, marks and age, and I have loaded data into a data frame object, and then I am printing the value of the data frame. So let me run this cell, and you can see the output. You can see the output in the table form. There are two columns, marks and age, and there are 3 rows, you can see. Okay, so next is how you can use location attribute to return one or more specified row. For example, this data frame has 3 rows. Now I will use location attribute to return one or more specified row. For that you will use print df dot location. So location value you will use, and if you run this command you will see the value of only first row. As you can see, the first row has values 320 marks and age is 21, and you can see like this. And if you want to return multiple rows, then you will use df dot location, and here you will pass the particular location. And if I run this, you can see your original data frame has 3 rows. As you can see, marks age for the first row, marks age for the second row, marks age for the third row. and if you pass 0, 1, it means 0 index and 1 index, and you can see the corresponding output. Now by default these has the 0, 1, 2 indexes. We can also use named indexes. So in this part I will use named indexes. So with the index argument you can name your own indexes. So with the help of index argument you can use, for example, let's use named indexes. For example, in this case you will use df equals to dot data frame. The name of the data is coming from student, and I am giving the indexes like this. So indexes are, for example, Pankaj, Sunny and Rahul. And now I have given the indexes name. Now if I print df, so let me show you the output. You can see now the indexes previously has 0, 1, 2 value. Now I have changed the index values to this, because Sunny, Rahul, and you can see the output. And similarly you can print the value of a particular student. For that, you will use df.location, and previously in the location method I passed the index, because by default these rows have 0, 1, 2 index, but now I will pass the name of the index, because now the indexes has the names. So I will pass the name of the index. So for example, I want to see the data of Pankaj, just click on run, and you can see like this. So this is the basic introduction to Python data frame. Okay, so practically we can use Python data frame to load the data from the CSV file for the better data analysis. For that, what I will use a read CSV file for the basic understanding of the data, and how to load the data from the CSV file I will discuss now. So this is my data set. This is dataset, and it has the data of you can see of around 500 data. It has that 500 rows, more than 500 rows, and you can see the different columns. So first of all, how to load this CSV file into the Pandas. So for that, here is the location of my CSV file. So for that, what you will do, so let me create a new notebook. So just wait while new notebook is being created. Okay, so here I will first of all import Pandas as, and here data, I will now read the CSV file. So pd dot read underscore CSV. So read underscore CSV function is used to read the data from the CSV file, and here I will use this file. So project data file I will use. So I will simply, you can see, I will copy it and here I will paste it. So it will read the CSV file from my local storage, because I want to read the data of this CSV file, and how Panda will help me in analyzing this data set I will explain. So first of all, let's quickly print this data and click on run, and you can see the my data has 499 rows and 12 columns. So if you are able to see this output, it means your data has been successfully read. Now what we can do, if you want to print only the first 5 rows, so first 5 rows of data, then simply you will use data dot head function and click on run, and you can see only there are 5 rows in my data. And if you want to print first 10 rows, if you want to analyze the first 10 rows, then what you will do, you will use data dot head, and here you will pass the number of rows. And now my data has 10 rows, as you can see. And if you want to print the last 5 rows, so last 5 rows, you will use data dot tail and then click on run, and you can see the last 5 rows data. So in this part I am only covering the basic functions like head, tail, and how to load the CSV file into the Pandas data frame. And I have covered what is data frame, so how to load the file, and how to use the head function and tail function, how to print the particular rows, first 10 rows. And now if you want to find the information about your data, so information, for that what you will do, you will use data dot info function, and let's see the output. And what data dot info function returns number of rows, you can see from the output, and the number of columns. And number of columns, there are 12 columns, and 0 index column is customer ID, year of birth, educational level, marital status, annual income. So I am able to analyze my data with the help of data.info. In the coming lecture I will cover more functions related to data frame. So in this part I am only covering head, tail, info. So you can see all the column names in the output, and all are non-null, and there are 499 values in each of the column. Okay, so there is another property, data dot shape. So what does this data dot shape means? It will return the number of rows and number of columns in the data frame. So there are 499 rows and 12 columns. So remember these basic functions, simple functions. Data.head means first 5 rows. Data.head, if you pass the number of rows here, it will print the particular number of rows. Data.tail, data.info will provide you the name of the column, okay, and data.shape provides the number of rows and number of columns in the data. So in this part I will cover only this portion. In the coming part I will explain more functions of data frame so that you can better analyze the data. So that's all. Thank you for watching. Hello everyone. In the previous part I have discussed how you can use Pandas data frame, what is data frame, and some basic functions of data frame. So in this part I will explore some more functions of data frame, and we will analyze the data set. The data set which I am gonna use is available here. You can see the data set, and we will analyze this data set with the help of Pandas data frame in this part. For that you must import pandas as pd, and then I will use pd.read_csv to read the data from this link. So just copy this link and then paste it here, and then when I click on df it will print all the data. So as you can see there are these number of rows and 21 columns in my data set. You can see all the columns here. So you can see all the columns here. When I print df it will print a whole data set, as you can see. Next is df.columns. When I use data frame dot columns, then what is the output? I get all the columns. For example, you can see the columns age, job, marital, education, default, housing, loan, contact, and all the columns you can see in your data set, as you can see. So when I click on df.size, it will print me the number of values in my data set. So number of values in my data set are, you can see these number of values are in my data set. And df.shape I have also explained in my previous part. df.shape will print the number of rows and number of columns in my data set. Very simple. And df.describe, it actually provides the summary of the statistics. So when I use df.describe, it provides me these values for each of the column. It provides me count, mean, standard deviation, minimum, 25% variance, 50%, 75%, and maximum value. As you can see that if I see the age column, there are 41188 values in count column. Similarly all the columns has these number of values, and minimum age is 17, maximum age is 98. Similarly you can find the minimum duration, you can find the maximum duration, you can find the statistics of each of the column, as you can see. And similarly you can find the mean of all the age value, you can find the standard deviation of all the age value, minimum of maximum value. Next is df.dtypes. Df.datatypes will provide me the data type of each of the column. As you can see, age is integer value, job is object value, duration is integer value. So there are some float values in my data set. So you can find the data types of each of the column. Next, When I click on df dot when I type df dot data type dot value underscore count, it will provide me the number of integer columns in my dataset, the number of float columns in my dataset, and the number of object type columns in my dataset. df.head, I have also explained this in my previous video. It provides me the first 5 rows of my dataset. As you can see, the first 5 rows of my dataset you can see on the screen. Very simple. And df.tail provides me the last 5 rows of my dataset. So df.head provides me the first 5 rows, and df.tail provides me the last 5 rows of my dataset. And if you want to print only the age column, you can simply pass df square bracket and then age column, and it will give me the output of the it will provide me the data of only age column. As you can see, name is age and length is this one. It means there are so many values, and data type is integer 64. And similarly, you can print the df job. So it will provide you the job of the each of the row. You can see 0 is housemaid, 1 is services, and so on you can find. And if you see you if I click on df job, it provide me all the values. For example, this value and this value has services job, you can see. And if I write df job dot value underscore count, it will provide me the data category wise, job category wise. For example, the number of the number of job where the job is admin is 10422, blue collar is 9254. So this way you can print the value count of any of the column. Simply provide df square bracket name of the column dot value underscore counts. It's very easy. And if I type df job dot value underscore count normalize equals to true, it will provide me the percentage of that. For example, the number of admin jobs are 0.25%. It means 25% of all the values which are in the dataset. There are total values if of the dataset, there are 25% values of the admin, 22% values of the blue collar, 16% values are of technician. So if I provide normalize equals to true, it will provide me the data like this. And if I so see, now this value has 0.253035. I can round off this value to 2 decimal places. So simply just provide the function name round and pass this value comma 2. So it means it will round off the value by 2 decimal places. As you can see, compare these results. Here I have provided normalize equals to true, and here I am rounding off the value to 2 decimal places. Similarly, you can filter the data. So if I provide df dot location colon 6 comma this, it means it will provide me the first 7 data points. It will provide me the first 7 data points using the location method, but for the variables job and marital. So it will provide me the first 7 values of the job column and marital column. It's very simple to use this. And similarly, we can achieve the same result by using iLocation. If I use location method, if I use location, then I have to provide the column name. And if I provide the iLocation, then here I have to provide the column name as the integer value. So 1 comma 3 integer value means, see my complete data set. So see, this is the 0 index, this is the 1, this is the 2, this is 3. So I will provide 1 comma 2 or 1 comma 3. You can type here. So okay, so I location 1 comma 3, it means job and education. So let me show you the data. 0 index is age, 1 index is job, 2 index and 3 index. So job and education column means I am getting the data of only these 2 columns. So with the help of iLocation, I will provide the column as integer, and with the help of location I will provide the column name. So this here I am printing the whole my data set. Okay, so conditional selection. For example, if I want to select only data where the age of the person is greater than 50, then what I will do, I will use df age greater than 50 and then I pass it in the data frame. So very simple, it is a conditional selection. So here you can see I am getting only 7180 rows because only these number of rows has is greater than 50. And similarly, see, if I write like this, I am getting all the columns. But if I am not interested in getting all the columns, if I am interested in only particular columns, then what I will do, I will use df dot location and then see the difference. Here I am getting all the values which where age is greater than 50, and here I am getting only these two columns. So very simple, df dot location. Here I will pass the condition and here I will pass the column name which I want to print. So I am getting only the age and job values of all the columns, all the rows where age is greater than 50. It's very simple. Similarly, you can drop the columns in the result. For example, if I want to, if I am not interested in these two column job and education, I can drop in my result. So df dot drop, and in the scale in the bracket I will pass columns. In the bracket I will pass columns name. So job and education I don't want in my result. I want to drop these two columns. I will pass in the. So you can see now I am getting only 19 columns, and in my original data set there are 21 columns, and I have dropped two columns job and education. It's very simple. So this way you can drop the as many number of columns as you want. Just pass the column name here. And if you want to add a new column, so simply, for example, I want to add a new column. See, in my original data set I have 21 columns, and now I want to add new column. So df in the square bracket I will pass the name of the new column equals to the value. So it will has English value for each of the row. So you can if I print df, you can see there are 22 columns. In my original data set there were 21 columns. Now I have added one new column, English language, and now I have 22 columns. And let me show you the values. So you can see the last column is language English. So I have added this column to my data set. Very simple. And you can see the name of the index of index starting from 0 1 2 3. And if I want to rename the indexes, I can rename. So df dot rename, in the bracket I will pass the index. For example, 0 index is Rahul, 1 index is Ram, 2 index is Rajan. And when I print the data, you can see 0 index, 1 index and 2 index are renamed to Rahul, Ram and Rajan, and I have not renamed the remaining indexes. So I am getting 3 4 and these values, but I have renamed the 0 index, 1 index and 2 index. So I am getting in the result the name of the index, the new name of the index which I have just renamed. So 0 is Rahul, 1 is Ram and 2 is Rajan. Very simple. And similarly, you can also rename the name of the columns. For example, if I want to rename my column education to edu and day of week to day, education to edu and day of the, so you can write like this, df dot rename columns. See, previously I have renamed the index. So index is row wise, but now I want to rename the columns. So df dot rename, and in the columns I want to rename education to edu and day of week to day. So just type this, and you can see in the result of, in the previous result, see the name of column was education and now it is edu. And similarly day of week, see a day of week, and now I have renamed to day. As you can see, I have renamed the column to day. Previously it was day of week, now it is day. Very simple. So this way you can use the all the functions of the data frame for better analyzing the data. That's all for this lecture. Thank you for watching.